Welcome back, everybody. In our last video, we made some great improvements to Guess Game 2 and Guess Game 3 with mostly formatting, and we also made it so that we could pick a number between 1 and whatever, and we fixed that value error we had. Alright, like I previewed in the last video, this video will be about writing a function so that our number of guesses is dependent by our variable x. So let's make a new file. As you probably could guess, I'm going to name this one guessgame4.py. Let's go to guessgame3. I'm going to copy all this, command copy, go over to guessgame4 and print it out. Alright, so in this one we're going to make that function and we're going to clean up the last little bit of aesthetics. So how are we going to make this function? So let's think about it. If our number of guesses needs to be dependent on our value of x, what type of function should we do? Let's go over to a blackboard so we can work this out. Alright, so I'm not sure how much you guys are aware of this, but there is this notion called binary search. Now, what is binary search? It's a more optimal way to pick a number. Like whenever I was picking a number between 1 and 10, I would choose 5 because it would split it into two equal groups right in the middle. So imagine for a minute if we have this line that represents a bunch of integers. Now linear search, let's say that our destination was here, our hidden destination. And linear search, we just started at 1 and slowly counted up. Well, if we were unlucky and our destination was here, it would take us forever. So binary search is it takes our path and it cuts it in half. So we will cut it in half and then try lower, try higher. Let's say it was try higher. We cut it in half, try lower, try higher, etc., etc., etc. With infinite numbers, you could do this however long you wanted to, but luckily we're dealing with a finite number of integers, so we'll eventually have a terminating point. So we will find our answer pretty fast using binary search. And this is a more optimal way, so let's make our function around binary search. Alright, so this is what it is. This is the explanation, but how can we put this into math terms? So let's use a quick example with numbers. First, recognize this has to do with halving numbers. So let's start with small numbers. Let's choose 8. 1, 2, 3, 4, 5, 6, 7, 8. Now this is an even number, so we can't cut right in the middle. But let's do 4. And let's say we were unlucky this whole time. So it gave us this, it said try higher. We split in the middle again, 6, try higher, 7, let's say we were wrong, still try higher, 8. So this took us 4 guesses. Okay, what about 7? What if we chose pick a number between 1 and 7? 1, 2, 3, 4, 5, 6, 7. Okay, this is an odd number. It will split right in the middle. It will say try lower. So mark these out. 2, split in the middle, try lower. Mark it out. So it will take us at least 3 guesses. So the split is between the 8 and the 7, and we're dealing with halving. So can you guess what we're going to be using? I hope you thought of it. This function is based off of powers of 2's, so 2, 4, 8, 16, 32, etc. So for 2, anything 2 So for 1, you of course need 1 guess. For 2, worst case scenario, 2 guesses. For 4, you would need, worst case scenario, how many? You would need 3 guesses. You would count it, say upper, no, yes. So this would be 3 guesses. This would be 4 guesses. This would be 5. And these are the turning points. So 8 to 15 would be 4 guesses. 16 to 31 would be 5 guesses, etc. So how can we model this? So we'll say our number of guesses equals what? Well, how can we find this number? Well, we're dealing with powers of 2, so we can use a logarithmic function. I know you all thought you would never see this again in your life after you took algebra class, but logarithms are actually a very useful tool. So we have log 2, we'll input our x, and then our output will be our guesses. But I know if you're math savvy, you'll already see this. If I input 8 into this, log 2 of 8 equals 3 because 8 is the third power of 2. So what we're going to have to do, and it takes 4 guesses for 8, so what we're going to have to do is we need to add 1 here. This way, whenever we input 8, it will give us a number larger than 3. It will give us 3 for log 2 of 9, it's about 3.17-ish. It's equivalent to this. Alright, and we want this number to round up to 4, to give us 4 as our integer. I know that usually you would round this down, but in this case, we want to round up. Anything larger than 3 will go to 4. If it's 3 exactly, it can stay at 3. And that's why if we input 7 for our x, we would have log 2 of 7 plus 1, which would equal 3 exactly. And therefore, 7 would have a guess range of 3, as it should. Alright, so now that we know the function we're going to use, let's head over to python.org and see if there's any useful library tools. So go to Documents, Library Reference. I remember when we searched for random, we're in the math category. Okay, let's go to Mathematical Functions. Let's look at this first one, ceiling. Return the ceiling of x, the smallest integer greater or equal to x. Well, that's exactly what we need. If basically this is saying if we have 3.001, it's going to return 4, which is what we need. And if we have 3, it's just going to return 3. Alright. And is there any logarithmic functions? Let's scroll. Yes, there is. Oh, log 2. Return the base 2 logarithm of x. This is usually more accurate than log x of 2. Alright, so we could do this first one, log x comma the base, but this one says it's more accurate, so let's just go ahead and use it. So let's go back over to Atom. We're in guess game 4. So let's start our code. So while the length of guesses, this is still length of guesses, this doesn't change, but instead of less than 4, this will be less than, let's say, some variable n. So now we need to define n, and what is n going to be? Well, n is going to be the ceiling of the log 2 of x plus 1. And we need to import all of these. So just like where we inputted the rand int, we're going to say from math import ceiling and log 2. Okay. And then I also think it would be nice if it told us how many guesses we had. So just right here, let's just say print All right. You have blank guesses. Dot format in. And again, we need to put this in quotes. There we have. That looks good to me. And let's put the backslash in here. I'm sure that will look good for our formatting. Alright, I think that's all we need. Let's save our program, Command save, open it up in the terminal. As always, we're using Python 3, and this is guess game4.py. Pick a number between 1 and 100. Alright, you have 7 guesses. Our function worked. It told us how many guesses we had. And here we are. Let's try 50, try lower, 25, try higher. Okay, split the difference. 12 more will be what? 37. Try higher. Okay, 13 more. Split the difference of about 7, so 43. Try higher. Okay, between 43 and 50, difference of 7, we'll just go up 4 to 47. Try higher. Okay. So it's either 48 or 49. 48. You won. The answer was 48. Would you like to play again? No, I would not. There we go, guys. A beautiful program, beautifully written and understood. All of the aesthetics are great for this. I can't think of any more improvements. I think this is a great final program for Guess Game. If you have any questions or comments, please leave them below. And if you found this video helpful, please like and subscribe to my channel. Cheers.